describe a related technology called augmented reality. This puts computer-generated content into the real world. By show of hands, how many of you have played Pokemon Go? That's augmented reality. It puts a virtual object, a Pokemon, into the real world. AR also exists in Snapchat filters, which put virtual facial features onto a real person. 7 years ago, Microsoft released this demo. It's Minecraft on a table. For those of you who haven't played Minecraft, it's a sandbox game in a world of blocks that's very creative and immersive. This brought it from the screen to the real world. You could reach out and touch the blocks. The person in that demo was wearing an AR headset. Like a VR headset, an AR headset is something worn on your head, but it doesn't need to be bulky. In the future, we will have AR smart glasses. Instead of closing you off from the real world, you can see what's around you while playing a game. In other words, you won't run into your furniture by accident. I recently attended a webinar at Virginia Tech where they have an entire institute dedicated to augmented reality. More specifically, they research how this technology will change our everyday lives in the near future. According to Virginia Tech, smart glasses will eventually replace smartphones. For example, measure how long it takes to check your email. Pull your phone out of your pocket, unlock it, find your email app, find your newest email, turn off your phone, put it back in your pocket. That took 15 seconds. Now imagine if you had smart glasses. Look to the right, tap your newest email. That took 2 seconds, a fraction of the time. So AR is useful for immersive games and quick notifications, but its real promise is something far greater. For example, magic is not proven to exist in this world. Well, maybe. Some would consider that modern technology is magic. But AR can bring things like magic from fiction into reality. When I was young, I was fascinated by Star Wars. Jedi Knights had a power called the Force, where they could move objects with their mind. Last summer, I made a demo that emulates using the Force on a lightsaber. Using AR, I may have become the first Jedi Knight in this world. The last time one single technology had so much potential was the World Wide Web. But like all major technological advancements, only a few people get to try it at first. Today, an AR headset costs $3,000. That's a lot of money for one gadget. I'm not paying for it, and my parents definitely aren't. But if you work as a surgeon or a factory worker, your company just might let you try it. This unequal access to such a wonderful technology is unfortunate. People have so many ideas that could become reality using AR. But because an AR headset is so expensive, these ideas are never realized. In 2020, there were rumors that Apple would release an affordable pair of smart glasses. They would cost $500, which is less than the cost of a smartphone. Finally, I could access technology that turns any idea into reality. But at the end of 2020, there was nothing. Silently, Apple decided not to announce anything related to augmented reality. In fact, the release date for smart glasses now stands at 2025. I was done waiting for other years to bring this technology. For my senior project, I turned a piece of cardboard into the first affordable AR headset. Google Cardboard is something that turns an iPhone into a VR headset. You put the phone inside, and the phone displays virtual content. To make it AR, capture video of the real world using the phone's camera, then put that video into VR. The newest iPhones also have a 3D scanner that maps their surroundings in 3 dimensions. Instead of making the video a 2-dimensional flat rectangle, it can be a 3D mesh that matches the shape of the real world. This VR video is a 3D modeling app where the white spheres represent my hands. But while it's playing, pay close attention to what's in the background. It's my bedroom. Here's a closer look at what you just saw. Here's my computer monitor, my keyboard, and my walls. But something very important is missing. Real color. They're all orange and green, which does not reflect reality. That's because there was no way to map 2-dimensional video onto 3-dimensional shape. So I invented something called scene color reconstruction. This algorithm tracks the color of everything in your surroundings in real time, gathering more data over time. Even when the camera can't see something, it knows what the color should be. In this image, my hand blocks out a large portion of the surroundings from the camera's point of view. The camera's autofocus detects the hand and focuses on it, making the background blurry. But the hand is visible. That's because scene color reconstruction erases the hand and replaces it with a guess at what the background looks like behind it. It's almost impossible to distinguish what color is real from what's generated by a computer. All of this complex computation comes at a big cost. It's power hungry. 5 minutes into an AR session, the iPhone begins to overheat. To cool itself down, it throttles the frame rate. How many times the screen updates per second? Yet virtual reality experiences strive for the maximum possible frame rate. Having less frames per second makes the experience a lot less comfortable. To solve this problem, I optimized my software for power efficiency. This made it a lot more complex and difficult to get right. I faced several troubling bugs while implementing optimizations. This is supposed to be my desktop. Because one line of code was off, the entire rendering process was corrupted. Here, my phone froze in the middle of a render pass. It wrote to part of the screen, but did not finish what's in ink. Seconds later, the app crashed. just mesmerizing. I could spend hours watching it. I wanted to have one in the real world, but I didn't want to be limited to just 2 pendulums. What if there were 3 or 4 or 100? Would the motion be more complex and unpredictable? Sadly, having more than 3 pendulums in the real world is impossible. Damping and conservation of energy will bring it to a standstill in seconds. But using AR, I can bring this perpetual motion machine from diction into the real world. The first affordable, accessible AR headset experience was AR Multipendulum. This app is published on the Apple App Store and available for free. Even if you don't have Google Cardboard, you can still try it out as a standard handheld AR app. At this point, the average person could access an AR headset experience, but nobody could repurpose my code for anything besides AR Multipendulum. So I made a second product, an open source software framework called AR Headset Kit. A framework is a general purpose code base that developers can utilize to make apps, along with source code and needs documentation to show people how to use it. I made 5 hours worth of tutorials to show anyone how to make an AR app using this framework. All they need to follow the tutorials is a little bit of experience programming. At the beginning of this presentation, I said that AR headset technology was not affordable. Because of this lack of accessibility, the average person could not try or create true augmented reality experiences. Now that dynamic has changed. People can finally bring anything from their imagination into reality. Thanks to Mrs. Graves for guiding me throughout the senior project, to Mrs. Jennifer Kim